This is a continuation of homework set 21, solving rational equations. Let's start this question 8 by getting the LCD. We will factor this denominator. So let's just rewrite the whole thing. We've got 1 over x minus 2 minus, all right, subtraction this time, 2 over x plus 3. Let me write that so it's actually readable best I can, equals, okay, 4 over, let's factor, x and x, how about plus 3 minus 2, and what do you know, they just happen to match our factors over here. So our LCD is, we've got that x minus 2 appears, the x plus 3 appears, and excluded values, x cannot be 2 from the form right above it, and negative 3. Right, that's going to give us division by 0. So we need to exclude those values. So let's do this. Let's take our LCD and write it in front of every original term. So we'll get this. X minus 2, x plus 3, dot 1 over x minus 2, minus, okay, x minus 2, x plus 3, dot 2 over x plus 3, equals x minus 2, x plus 3, dot 4 over x plus 3, x minus 2. So a lot of writing. But now let's see what cancels. So this x minus 2, I'm off to the left here. X minus 2 will cancel with that x minus 2, and we are left with 1 times x plus 3. So how about x plus 3? And then we've got a minus. Okay, so what's happening over here now? In the middle, that x plus 3 will cancel with that x plus 3, and we're left with this 2 and the x minus 2. So I'll just write that 2 and then x minus 2, and I'll multiply through in the next step. Equals, and then over on the right side of the equal sign, the x minus 2's cancel, x plus 3's cancel, and we're just left with that 4. Let's multiply through here. About x plus 3 minus 2x plus 4 equals 4. And on the left side, that x minus 2x is negative x. 3 plus 4 is a 7. That's equal to 4. Let's subtract that 7. I'll do it up here at the top. So I'll get negative x equals, now subtract the 7. 4 minus 7 is negative 3. But this is the opposite of x, not x itself. So let's multiply or divide by negative 1. So if negative x is negative 3, then x itself must be 3. Now that's a potential solution. So let's just check. Run it back by our excluded values. All right, I'm getting that we excluded 2 and negative 3. We got positive 3 here, so we should be okay. So let's conclude that x equals 3 is the solution to this equation. Question 9 asks us to solve this equation here for y. So we've got x equals, I've got x on the left, y is on the right. Let's solve this for y. So we have that y equals something. Now, got a denominator, so let's get the LCD, which is y plus 5, and of course y cannot equal negative 5. All right, so multiply both sides by that LCD. That amounts to just taking that LCD and putting it here and here. Just put it in front of all the originals, so we'll get this. I'll write it this way, actually, x, and I'll put the y plus 5 here, equals, how about y plus 5, dot, y plus 6 over y plus 5. Now, over on the left side, multiply through, we'll get xy plus 5x equals, and the right side, the y plus 5's cancel, and we get y plus 6. Now I'm trying to solve for y. I see y on both sides, right? I've got it here on the left side, and I've got it here. Why don't we subtract this y? I get the y's on the left side. So that will give us xy plus 5x, and then subtract that y equals, I got 6 on that side. Now, I'm trying to solve it for y, so let's get this 5x. Let's eliminate that. So let's subtract that. So I'll get xy minus y equals, I'll get 6 minus 5x. Okay, I just subtracted this. So I'll get the 6 minus that. And now I'm going to do this. Well, what do you got over here? You got y's in both terms, right? You got y in both terms. So let's factor that out. I'll do it up here at the top. I'll get y, and then what's left? X minus, okay, now, what are you going to take here? Y times what will give you y? It's a 1. So what I'm taking out matches what I have. So when that happens, you get a 1 in that place. So I'm asking y times what will give me a y? Well, that's a 1. Okay, and then on the right side, we've got 6 minus 5x. X minus 1 is multiplying that y, so let's divide by that. So we'll get y is equal to 6 minus 5x all over x minus 1. And there we go. And our question 10 is similar to question 9. We want to solve this for y. Okay, solve for y. And you notice that you've got x on one side and all y's on the other. So let's get the LCD like we always do and eliminate that denominator. So the LCD here is that 2y plus 2. Now what do? You take the 2y plus 2, the LCD, and you write it alongside every original term. We're just multiplying both sides by 2y plus 2. So I'll get x, and then times that 2y plus 2 equals, now I'm going to write 2y plus 2 times the 3y plus 3 over 2y plus 2. Now on the left side, I'll multiply in. I'll get 2xy plus 2x. And on the right side, those denominators cancel. So I get 3y plus 3. Now I'm trying to solve for y. So I've got y's on both sides, right? I got it on the left side here. And I've got it on the right side here. So choose a side. I'm going to go with the left side. So I'm going to take this 3y and subtract it from both sides. All right, it'll look like this now. 2xy plus 2x minus 3y, right, I'm subtracting it, equals 3 is all that's left. And now, let's get rid of that 2x. So let's eliminate that. Let's subtract that from both sides. So I'll get 2xy minus 3y is equal to 3 minus 2x. And now I've got the y's just on the left side. And I know I've got one here and one here. So I've got y common to both terms. Let's factor it out. I'll do it up at the top here. Factor out that y. What's left? If you remove a y, you're left with a 2x and then a minus 3. And that's equal to 3 minus 2x. Okay, let's see about that. All right, so I'm going to divide by that. So I'm going to get y is equal to 3 minus 2x over 2x minus 3. And we'll leave the answer just like that. But there is something you might do. 3 minus 2x. Now I can write that as negative 2x plus 3, right? We good with that? And then what I'm going to write is negative 2x minus negative 3. So I'm using some algebraic techniques. Some call them tricks. But let's see what we can do with this. Now I'm going to write here. I'm going to write negative 1 times 2x minus 1 times negative 3. Right, I'll just put 1's in there, just multiplying by 1. Now I notice I got negative 1 in both of these terms, so let's factor it out. So if I take out negative 1, what I'm left with is 2x and then minus 3. All right, now then I've got this. Now just coming from right over here, we just played with this a little bit. Here's what I'm going to have. I would have y equals, now that 3 minus 2x, we just saw I could write that as negative 1 times 2x minus 3 over, okay, that's this part right here, over the 2x minus 3. And that cancels, and then I get this, y equals negative 1. All right, so that's the top. That is another way to write this numerator up here. 3 minus 2x, I can turn it around as negative 1 times 2x minus 3. Then, if I put that all the way back here, here's what it's going to look like. We would have that y is equal to, now instead of 3 minus 2x, write it as negative 1 times 2x minus 3 all over, what, 2x minus 3. The 2x minus 3's cancel, and we're left with y equals negative 1. All right, but here's a problem. If y is negative 1, what am I going to get? Put it back into the original. Put negative 1 here and negative 1 here. And what you get is that x is equal to 3 times negative 1 plus 3 over 2 times negative 1 plus 2. So x is equal to negative 3 plus 3 over negative 2 plus 2. You get x equals 0 over 0, which is, we call that indeterminate, which does not define any real number. So clearly, y cannot be, all right, y cannot be negative 1. But that's the only restriction. So y can't be negative 1. So what is y? Well, here's another way to look at this. We started out with this equation here. X equals 3y plus 3 over 2y plus 2. Now, let's factor. X is equal to, take a 3 out of the top, y plus 1, take a 2 out of the bottom, y plus 1. Those cancel, and I'm left with this. X equals 3 halves. Now, there is no y in this. All right, this is independent of y, which means that y could be any number. Here's a way to write it mathematically. Y could be any number in this interval, negative infinity to negative 1 or 1 to infinity. All right, so what is y? Really, it's not what we wrote up there, even though that's what is in the book. This is what y could be. Pick any number at all, any number except negative 1. That's what we're saying up here, up at the top. Y can be any number except negative 1. And that finishes up all the problems in our homework set 21.